Hello, I'm Regina. Welcome to my Lab 3 for Physics 2211. Today we're going to talk about black holes. So a quick overview of what we're going to go over today. First, we're going to go over the purpose, then we're going to go over fundamental concepts for today's lab. We're going to do a quick experiment summary, and then we're going to move on into our experiments and go over the code and discuss our results. Today's lab has two parts. The purpose of the first part is to analyze the star's motion to find the net force on the star and also determining the mass of a black hole by using our computational model. For the second part of our lab, the purpose is to determine the initial velocity of a ship when it leaves the surface of a planet and simulate the motion of the spaceship around the planet and the black hole. We're also doing this by applying Newton's second law. Some fundamental concepts that we should be familiar with for this lab involves Newton's second law, which states that the acceleration of an object is dependent upon the force acting on the object and the mass of the object. And other concepts include parallel component, which changes the speed, and perpendicular component, which changes the direction of the momentum. On the bottom of this slide, you can see both formulas, the parallel being the one on the left and the perpendicular being the one on the right. In order to carry out these experiments, we wanted to analyze the data points in our dataset by making use of our computational models, and finally, we also compared and analyzed the results of these computational models. For experiment 1, we were given the starter code that we needed to complete. In order to do so, I first established the initial components, which included the seed, the mass of the star, and the time, which you can see in the left side of the slide. In this case, our system was the star and the surroundings were the black hole. Next, I had to edit the calculation loop. In order to do this, I first calculated the momentum vectors, which you can see in line 164. Next, we did the change in velocity and change in momentum, which you can see in line 168. Then, in order to get the parallel component of net force, we calculated the change in magnitude in the momentum over change in time, times p hat, which you can see in line 178. Then, to get the perpendicular component, we subtracted the parallel from the net force by making use of the Fnet formula. Finally, to get the mass of the black hole, we made use of the gravitational force formula and solved for the mass. You can see this in line 193. Here are the results that we get from running our experiment 1 code. As you can see, our star is going along the green axis and it's the yellow ball. And our black hole is symbolized by the black dot in the center of the screen. And here are the results that we get from running the simulation, as you can see in the screen at the bottom. Moving on to experiment 2, we were also given a starter code that we needed to complete. In this case, our system was the spaceship and the surroundings were the planet and the black hole. Our initial conditions consisted of the black hole mass, which we got in part 1, and the ship speed xy vector, which we got through trial and error. Next, for the calculation loop, we first wanted to calculate the motion of the spaceship and the planet, which we did by computing the net forces of both of them accordingly, with the gravitational force equation, as you can see in lines 89 and 107. Finally, we also calculated the updated position for both of them, as you can see in lines 116 and 117. And here we have the results from experiment 2. The cyan line represents the orbit of the planet, and the pink line represents the direction of our spaceship. Again, we calculated the XY speed through trial and error, and this is just one of the ways that we can evade the black hole. Now, some possible errors that we could have had in part 1 would be inaccurate calculation of the mass of our black hole, and for part 2, some possible errors also involve the calculations done incorrectly in the previous part, and also some slight deviation in the spaceship's velocity. Something that we want to discuss is how the net force and its parallel and perpendicular components are different from the rate of change of momentum and its parallel and perpendicular components. Well, the net force and its parallel and perpendicular components are extrapolated from the rate of change of our momentum of the object, which will end up having the same value. Another thing that we want to go over is what if instead of wanting to take a quick look at the black hole and leave, you decide you want to enter an orbit around the black hole? What initial velocity will your spaceship need to have in order to enter some orbit around the black hole? Well, in order to find this out, we will want to find the force that matches the force of gravity. Then there would have to be no net force and a constant velocity at an angle for this scenario to be achieved. And that is all for our lab 3. Thank you very much and bye.